In this video, we are going to talk about event-driven serverless microservices design with AWS Lambda. We will follow the AWS Lambda design principles and the best practices when developing our Lambda-based event-driven serverless e-commerce application. Event-driven architecture provides developers with increased agility, elasticity, scalability, and cost optimization. With the rise of microservices and the cloud, event-driven architectures is becoming increasingly important for developers in order to understand that. So AWS Lambda is a very good fit when developing event-driven architectures because the nature of the AWS Lambda executions trigger from the events. Events can come lots of resources and able to trigger AWS Lambda functions. The main purpose of the AWS Lambda function is to handle events. An event triggering a Lambda function could be almost anything. You can see on the picture in the slide, from the REST API HTTP request with Amazon API Gateway, a scheduled task management by an Amazon Event Bridge rule, or Amazon S3 notification like object uploaded into bucket. So these are the main example use case, but lots of possibility to invoke Lambda function with events. You can see in the picture there is lots of events comes from the AWS resources. Even the simplest Lambda based application using at least one event. So that's why we said that AWS Lambda is very good fit for event driven architectures because the fuel of AWS Lambda is event. So event driven architectures rely on creating events into all application state chains that are observable by other services, but the event publisher system is unaware of which consumers are subscribing that event. We call that these are loosely coupled services. Most Lambda based applications use a combination of AWS services for different requirements about storage, API management, and integrating with other systems and services. You can see in the image on the slide, these are the Lambda based invocation services, and most probably we will also use the combination of AWS services when designing the event driven Lambda based applications. In these applications, AWS Lambda is connecting between services and providing business logic to transform data that moves between services. Also, there are some design patterns and in the distributed architectures that we will follow when build and implement application using AWS services. AWS services has already implemented some of the distributed architecture design patterns that we can use easily without investing any time to develop these patterns from the scratch. So we will also follow these Lambda design principles and the best practices when developing our Lambda based event driven serverless e-commerce application. So here we can see the AWS Lambda invocation types into our serverless e-commerce application. We will map event driven Lambda invocation types. So AWS Lambda invocation types will be our serverless journey when developing our serverless e-commerce application. So during the course, we will follow these event driven Lambda invocation types as a microservices communication types of our serverless project. So we said that Lambda has three invocation types: synchronous, asynchronous, and event source mapping. We will follow these microservice communication types as a serverless invocation type: synchronous communication, asynchronous communication, and event source mapping for polling the queue events. So how we can follow these invocation types during the course structure? Let me explain one by one. First one is the synchronous communication for RESTful microservices. In synchronous model, the client makes a request and waits for a response. We will develop RESTful microservices with API Gateway, AWS Lambda functions, and DynamoDB. We call these RESTful microservices. REST API and CRUD endpoints with using the AWS Lambda and Gateway, API Gateway, and data persistence with AWS DynamoDB. So that means we will use AWS API Gateway for RESTful API driven development and performing CRUD operations with AWS Lambda and DynamoDB. So the second communication type is asynchronous communication. In asynchronous design, the client sends a request and may get an acknowledgement that the event was received, but it doesn't get a response that includes the result of the request. So we will use AWS Amazon Event Bridge for event-driven asynchronous communication between microservices. We will develop Event Bridge with AWS Lambda basket microservices, which is publish the event to the asynchronous way, and this will consume by the ordering queue and after that ordering microservices. So the third communication type is event source mapping for polling event message from the queue. In a polling event, consumers post the producer for message in a batch and then process the batch before returning for a new batch of records. So we will use AWS SQS for decouple microservices and processing events asynchronously using queues. We will develop AWS SQS with Lambda ordering microservices, which basically consumes by polling the event from the ordering queue. So as a summary, in serverless world, AWS Lambda is core service for building any event-driven architectures. That means we will also follow these Lambda design principles and the best practices when developing our Lambda-based event-driven serverless e-commerce application. Basically, we will group these events as a bounded context in order to develop the boundaries of microservices in our serverless application. So that means we will develop Lambda functions as a microservice into our event-driven microservice architecture.